Good afternoon, everyone. Today we're going to do a lesson about finding roots. Okay, so finding the roots of a quadratic function. And we did talk about this briefly during our kind of intro lesson, reviewing how you find the different things in a quadratic. So to recap once again, right, there were kind of three ways that we talked about to find the roots. So the first one was factoring. Right? If you can get it in factor form, then you can read the roots off the equation fairly quickly. The second way was that if we are in vertex form, okay, we could just solve the equation for x directly from there. And that was kind of useful yesterday when we were doing the inverse, because that's essentially what we ended up doing, right? We would switch x and y and then solve for y. So same kind of idea. From vertex form, you can directly solve for x. Well, last but not least, we can use the quadratic formula, which I'm sure Isaac is reciting for us, even as I speak here. Right, so once again, that lovely quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Okay, so those are three methods. So we'll do some examples and put some of this to use. Okay, so here's example one. Determine the roots of each of these following quadratics. Okay, so starting with f of x. Okay, we get 3x squared minus 22x plus 7. Okay, so again, ideally, we want to see if we can factor this. So we'll use our multiplies to what, adds to what method. Okay, so it multiplies the product of a and c there. So multiply is 21, adds negative 22. So my numbers would be negative 21 and negative 1. Okay, in this form, right, with leading coefficient being 3 there, right, we have to split the middle. So this is now 3x squared minus 21x minus x plus 7. Okay, and then we column factor each pair. So from the first pair, I can factor out 3x. And that leaves x minus 7. Okay, and from the second pair, I can factor out a negative 1. And that also leaves x minus 7. Right, we know we've done it right because we have the same bracket twice. So we have 3x minus 1, x minus 7. Okay. So for my actual roots, once I have the factors, okay, again, with enough practice, right, we know we can read these off. Okay, so for example, from the second bracket there, okay, right away we can say this gives me a root of x equals 7. Right, it's the opposite sign. Okay, for the other one, again, with practice, okay, you can probably see that it's going to be 1/3. Okay, but if you're not sure about that, just to refresh where we got that from, what I'm really doing is I'm setting that bracket equal to 0. Because I want to figure out what value of x would make it 0. So I bring the 1 over, then divide both sides by 3, and we have x equals 1/3. Okay, so I got my roots, 1/3 and 7. Okay, let's try the next one. So we have u of x equals x squared plus 10x plus 25. Okay, so again, this looks like we can factor it maybe, so we test it out. Okay, so it multiplies 25, adds to 10. Okay, my numbers are going to be 5 and 5. So I have x minus 5 and x minus 5 again. Sorry, not minus 5, plus 5. So that means I have x plus 5 squared. So it turns out this quadratic only has a single root, right? X is equal to negative 5. Okay, for my last one, I'll bring it down here. Okay, for x squared minus 5x plus 8. So we'll have a quick look here. Because again, you always want to try to factor it first. So it'd be multiplies to 8 and adds to negative 5. Okay, but that's not going to work, I don't think, right? We have 1 and 8, that won't work. 4 and 2. So yeah, this does not work. We can't factor it, so we go to the formula. So x equals, okay, negative b. So my b is negative 5. So negative 5, or just 5. Plus or minus the square root of b squared. So negative 5 squared minus 4 times 1, right, my value of a, and 8 is my value of c. Again, right? This would be a is 1, b, and c. Okay, and it's all over 2 times a, or just 2 times 1. So we start playing around with this. 5 plus or minus square root of. Okay, 5 squared is 25. And 4 times 1 times 8 is 32. So 25 take away 32 is negative 7 over 2. Okay, and you may have encountered this last year. I certainly hope you would. Okay, I have a negative square root. Right, if you try it on a calculator, it gives you an error. Okay, you can't take the negative as square root. So we're going to say, therefore, there are no roots. See, this does not have any roots. So before we go on to the next thing, just to recap here. So for no roots. So what does that look like on a graph, right? If it has no roots, that just means that our parabola doesn't cross the axis, right? So this was positive for A, so it opens up. So it just means that for whatever reason, the vertex of this parabola is above the axis. So maybe it looks something like that. Okay, I'm not going to worry about figuring out exactly where it is right now. So that's what it looks like, okay, when it has no roots. Okay, for this one, when we have the one root, okay, it is single rooted, x is negative 5. So that means this parabola just basically comes around, just touches the axis, and goes back up. So it is the lowest possible point, just sits on the axis, and that's it. Okay, the first case is the more typical case, right? Often a parabola will have 2 roots. This was like 1/3 and 7 way over there. Okay, so visually, those are the kind of 3 options, right? You can have 2 roots, 1 root, or no roots. Okay, which is summarized on the next page. Okay, so again, those are the 3 possibilities for the number of roots. You can have 2 roots, you can have 1 root, or you can have no roots. Okay, so for some reason we want to know how many roots without really needing to find out what they are. Okay, we can check for these using what's called the discriminant of the quadratic formula. Okay, again, I'm pretty sure you would have seen this in the grade 10 curriculum, but if not, Okay, all that's really talking about, okay, is the part of the quadratic formula that's under the root sign. Okay, that b squared minus 4ac, right, which you get from the standard form. Okay, so if I just remove that square root sign there, I just wrote down, okay, that portion, okay, that's what the discriminant is, okay, because the value of that tells us how many roots we're going to have. So for example, in the last one we did there, right, the negative under the square root sign indicated that we had no roots because I can't take a negative square root. Okay. And the reason this part is called discriminant, or it's so important, right, is also because of that plus minus, right? So that ties into this as well. So we'll talk about it down here. Okay, so the discriminant is positive, which means that this quantity, b squared minus 4ac, is greater than 0. Okay, if that value is bigger than 0, you're going to get 2 roots. Okay. Again, hopefully that shouldn't be too surprising, right? Because in the formula we had negative b plus or minus. So if this is a positive amount, okay, so some quantity like 1.5, 2, 700, okay, you're adding or subtracting that quantity. That's what gives you the 2 different options for a root. If the discriminant is 0, then we only have 1 real root. Okay, so if b squared minus 4ac equals 0, then there's only going to be a single root, right? Because again, if that's 0, okay, and I take the square root of this part, right, that would still be 0. So I have negative b plus or minus 0. So there is no change in the position. Okay, so my roots just really come from the negative b and the 2a. Okay, and finally, if the discriminant is negative, so if b squared minus 4ac is less than 0, then there are no real roots. Okay. When I'm back tomorrow, if you want to have a quick discussion of what you can do with a negative square root, we can certainly do that. But for the practical purposes here, like, there's no real roots. Okay, it doesn't have a solution for that quadratic. Oop, pardon me. Okay. So again, just to refresh that one more time, that original thing that we factored, right? We had 3x squared minus 22x plus 7. Okay. We wanted to know, if I wanted to know how many roots it had, but not actually solve for them, okay, I would just quickly do that calculation, right? B squared minus 4ac, and see what we get. So I have negative 22 squared minus 3 times 1 times 7. Pardon me, not 3, 4. Times 3 times 7. Okay. So now we just run this through. Okay, 22 squared is 484 minus 84. So that's 400. Okay, so my discriminant is positive. Okay, right? So this whole thing is greater than 0. Discriminant is positive. Therefore, 2 roots. Okay, that's basically how you use it. You just calculate that piece, and it tells you how many roots you would have. Okay, so for our final example in this note, we're going to use that a little bit differently. Okay, so for what values of k will the function x squared minus kx plus 16 have one root or no roots. Okay, you remember you kind of had a question like this on, I think, your very first assignment, right? It's like, well, for what value of b will this expression cancel out? Okay, so similar kind of idea here, right? What values of k can I put in there to get a single root or to get no roots? So starting with part A, if we only want one root, okay, I know I want my discriminant to equal 0. So we start with that fact. Okay, b squared minus 4ac should be equal to 0. Okay, I fill in what I can. So, right, my a value is 1. My b value is this negative k that's sitting here, and my c is 16. So, for me, I have k squared now. Minus 4 times 1 times 16. All right. So k squared minus 64 is equal to 0. Okay. K squared would be equal to 64. With 8 square root of both sides, that means k equals plus or minus 8. Okay, so if k is positive 8 or negative 8, okay, so my two equations would be like x squared minus 8x plus 16 and x squared plus 8x plus 16. In those two situations, I would only have one root. All right, so now let's do the case for no roots. Okay, if there's no roots, we talked about this not too long ago here, right? That means my discriminant has to be negative or less than 0. Okay, but this is going to play out almost exactly the same, right? I fill in my k, and I start rearranging. Okay, so eventually I'm going to get down to that same line up here. K squared is less than 64. Okay, just now it's less than instead of equal to. Okay, well, how do I solve this part? Okay, and it ties in to the root that we had up there. I had k squared minus 64. Sorry, k squared equals 64, and I got plus or minus 8. So I know this is going to involve the plus and minus 8 when I take the square root. Okay, if I want k squared to be less than that, okay, so let's forget about the negative part for a second. Okay, suppose I want to just be, and it was going to be positive. Okay, well, the square root, I'm going to draw a little number in here, that might help. Okay, if I want the square of k to be less than 64, then k needs to be less than 8, right? Because like 7 squared would be 49, 6 squared would be 36. Even 7.5 squared would be like 56 point something. So I need anything less than, anything between 0 and 8 would be okay. Okay, when I start going into the negatives, okay, that's also okay because negative 1 squared, negative 2 squared, those would be 1 and 4 respectively, but still less than 64. Okay, so really, I want k to be between 8 and negative 8. If it's anywhere in that range, or domain, maybe I should say, then it will be less than 64. So my answer to this is going to be negative 8 is less than k, which is less than 8. Okay, so yeah, between those values, that would be okay. And right, if you test some numbers out, if you don't believe me, test some numbers out. That will work. It's between negative 8 and positive 8 for the reasons we just talked about there. Okay, so thanks for watching. Your practice work is right here, starting on page 185. So we got some good time, work hard, and I will see you tomorrow.